Now we're moving into focusing on populations and specifically the human population. So chapters 5 and 6. So section 5.1 focuses on how populations grow. But before we can really look at how populations grow, we're going to spend a little bit of time talking about characteristics of populations. So there are 4 characteristics of populations that we're going to look at: geographic distribution, population density, growth rate, and population age structure. This last one here, not necessarily as important, but it can give us some supplemental information about the population, and again, give us some more information if we're going to be making decisions, that type of thing. So again, these characteristics are used to describe the population. Characteristics. So starting off with a geographic distribution. This is the range that the organisms live, or the area that they live. Pretty self-explanatory. So kind of their location and the range of that location. And that leads into population density, which is the number of individuals per unit area. So an example with this would be number per square mile. If we look at so focusing on the characteristics. The first one, geographic distribution. This is the range that organisms live, or the area that they live in. So specific area inhabited by a population. And this can vary in size from very small, like centimeters, cubic centimeters, maybe by bacteria in an apple, that type of thing, upwards to millions of square kilometers by migrating whales, that type of thing. So just recognizing that there is often a large range depending on the organism and the population that we're looking at. Population density, the number of individuals per unit area. So again, per unit area. And oftentimes we're going to see that, number per mile, that type of thing. So we actually could even do some calculations regarding that. This would be miles squared. And again, same type of thing. This can range greatly. So if we think back to our ecological pyramid here, I'll draw that. And if we're looking at a specific area here, and these are maybe our primary producers, this might be our primary consumers, that type of thing. This amount per this density is going to be larger than this. And this is going to be larger than maybe our secondary consumers, and so on and so forth. So we can kind of use that idea of the ecological pyramid to help when we think about population density. But again, it can vary to many to very few. And the last characteristic that we'll focus on is the growth rate. And this is the rate in which population increases or decreases. And we're going to move on to kind of more in-depth information on this. So what causes population growth? There are 3 different things that will affect population growth. Number of births, often called your birth rate, number of deaths, the death rate, and the number of individuals that are going to enter or leave the population. So immigration, they're going to come in to the population. They're going to enter the population. Emigration, they're going to exit the population. And again, depending on the rates of immigration and emigration, this can change the population quite a bit. So we're going to talk about different types of growth. So there are 3 things that are going to affect the growth, and we're going to look at how do these kind of play a role in different types of growth. So the first one we're going to look at is exponential growth. Exponential growth occurs when individuals in a population reproduce at a constant rate. So that would be the birth rate. So we're going to get a constant birth rate. And it requires ideal conditions. So unlimited resources, absence of predation and disease. So we'll show you an example. Look at the human population. So this is a human population growth chart, just a little example of kind of this exponential growth. So we have this constant birth rate, not really any type of tapering off, and we are going upward. So this would be an exponential. So when we think about it in math terms, this graph should look exponential. So that's great. However, this is rarely the case. Humans have a bit of an advantage in the fact that through technology and whatnot, disease and other things that might have affected our population have been kind of overcome. Our amount of natural predators have decreased, and we've developed things to kind of protect us. We have adaptations that protect us from some of the things that might harm the population growth. Majority of the species are going to see something called logistical growth. Okay, so we had our exponential growth that went kind of like this, saying unlimited resources, but as resources become less available to the growth of a population, then it's going to slow down. The growth of population is going to slow down. So instead of seeing this, we're going to see something maybe more like that, in the sense that that growth rate is not going to continue to increase as much as it has. When the growth rate slows down and levels off, the carrying capacity has been reached. So what is carrying capacity? Carrying capacity is the largest population of a particular species that the environment can support. And this is the big thing, is how much can the environment support? And we'll get more into this as we go into chapter 6, but really how big of a human population can the earth support? How, as we start using up some resources and using up our environment, how long can we sustain that? That's why you hear the buzzwords like sustainability, that type of thing. And it comes to this idea of carrying capacity and how much can the environment support. So here is just some examples of logistical growth and carrying capacity. So we look at a fur seal. Again, we kind of have originally more of this exponential, but what happens is as we get to that certain limit where the environment can no longer sustain that size of population. And at that point, it's going to level off. Think back to our oh dear exercise and remembering our graphs. When we started off with that, we had the population continue to rise, and then we entered this predator, and we got something like that for our deer and our mountain lion. Same is true. We got to that certain limit when we no longer had any resources. So what happened was is you had this really big deer population, and remember there was only a couple of other people standing on the other side. So at that point, at that highest level, that was the carrying capacity for that. So look here for our seal, and then we also have for the Daphnia population in a laboratory culture. Again, there's a certain kind of amount, and if we were to even follow this here, this looks more, the blue line looks more like what we expected in our oh deer population, kind of giving this idea that there was this exponential growth right away, but then it can no longer sustain itself. So that ends the notes for section 5.1.